Okay, so in this tutorial we are learning about support vector machines, SVM. Now what are support vector machines? Let's see it. A support vector machine is a classifier that is defined using a separating hyperplane between the classes. Now what will be here actually? So SVM is actually a classifier that is defined using a separating hyperplane. We are classifying our classes on the basis of hyperplane. We are separating our classes using a hyperplane, and that can be done using SVM classifier. So this hyperplane is the n-dimensional version of a line. So n-dimensional means we have multi-dimensions of that versions of that line, and that's why we are assuming here a plane that is multi-dimensional. Given labeled training data and a binary classification problem, the SVF find the optimal hyperplane that separate the training data into two classes. So if we are given as a binary classification problem as an input, then our SVM will find the hyperplane which will separating the classes because two classes, because we have two classes in our binary classification problem. So in that case, SVM will find the optimal hyperplane which will separate those two classes. And this can easily be extended to the problem with n classes. So if we have multiple classes, then we can also be used SVM for separating our different classes. Now let's consider an example, a two-dimensional case with two classes of points. So we have the number of classes we are assuming here 2, and the case with two-dimensional, that is 2D. Now in case of 2D, we will only deal with the points and lines in a 2D plane, or you can say in a plot you can consider. Now this is easier to visualize than vectors and hyperplanes in a higher dimensional space. So that's why we are using the 2D case as an example. Now see this graph. In this graph, we have used here two classes, class 0 and class 1. So class 0 is represented using the black circles, and class 1 is represented here by using black squares, small black squares. Now see, we have three different lines here, two dotted lines and one solid line. Now that solid line is representing actually an optimal hyperplane, and your dotted lines are not representing your hyperplane because they're not actually separating these two classes. That optimal hyperplane is actually separating those two classes data points. So there are two different classes of points and we have to find the optimal hyperplane. This is our problem. But how do we define optimal? Now what is the optimal? In this picture, the solid line represents the best hyperplane, and that's why we are assuming it is the best separator. This line is the best separator because it maximizes the distance of each point from the separating line. The points on the dotted lines are called support vectors, and the perpendicular distance between the two dotted lines is called the maximum margin. Now see this diagram. In this diagram, the distance between these two dotted lines is known as maximum margin, and the points which are present on these dotted lines are known as support vectors. Okay, now we will build an SVM classifier to predict the income bracket of a given person based on 14 attributes. Now we are taking an example and we are creating a Python program for that. Here we have to predict the income bracket of a given person based on 14 attributes. And our goal is to see where the income is higher or lower than $50,000 per year. So here we are taking $50,000 as a reference value and we are comparing our income with that reference value, which will be either higher or will be lower than that value. And for that we are using our census income dataset, which will be available on that link which is given. So see, use that link for getting the census income dataset if you want to use here. One thing is to note in this dataset is that each data point is a mixture of words and numbers. Now in this data point we have mixture of words and numbers, and we cannot use the data in its raw format because the algorithm don't know how to deal with the words, and we cannot convert everything using label encoder because numerical data is valuable. So we want here the numbers as our data. So for that we are using the combination of label encoders and raw numerical data to build an effective classifier. So we will use the combination of both these process to getting our data, and building an effective classifier, that is your SVM classifier. Now let's see how we can do this using a Python program.